Hello and welcome to Lucid Mind Chemistry channel with Majid. In this video, I'll be solving Chemistry A-Levels Multiple Choice Paper 12 from May-June 2021. You can go to any particular question by following timestamps given in the video description. Let's start.
Question 1. Which statement about the Avogadro's constant is correct? Part A. It is the mass of 1 mole of any element. Now Avogadro's constant is a number, it is not mass. And this number is equal 6 exponential 23. And it represents the number of particles present in 1 mole of any substance. So part A is wrong. B. It is the mass of 6 exponential 23 atoms of any element. Again, it is not the mass, it is the number. Part C. It is the number of atoms in 1 mole of neon. Now 1 mole of neon consists of 6 exponential 23 atoms of neon. Now this is a true statement. So therefore this could be correct option. Part D. It is the number of atoms in 12 grams of any element. Now this is not correct because every element has different molecular mass, so therefore the number of moles will be different. This statement can only be true for carbon because the atomic mass of carbon is 12 and number of moles in 12 grams of carbon will be 12 divided by 12 equals 1 mole. And it would be equal to 6 exponential 23 atoms of carbon. So this is only true for carbon, not for other elements. Correct answer is therefore C. Question 2. Which equation represents the first ionization energy of iodine? Now, ionization energy is the energy required to remove an electron from the outermost shell of an isolated gaseous atom. And first ionization energy would be the energy required to remove first electron from isolated gaseous atom. Now, isolated gaseous atom is always in gaseous form as it is given. All of the reactants are in gas. Now, first one is a molecule. It is not an atom as it is written as I2. Similarly, C is also a molecule. It is not an atom. So therefore, A and C are wrong. Now, among B and D, we can see that in B, 1 electron is added. This is electron affinity, it is not ionization energy, while in D 1 electron is lost to make it unipositive ion. So D describes the correct equation for the first ionization energy of iodine. Question 3. The structures represents 3 compounds, each with 4 carbon atoms per molecule. Which row is correct? We have to find out that which one gives the lowest boiling point and which one has the highest boiling point. In the first one we can see we have carboxylic acid functional group. In Y we have ester functional group. In Z we have sodium salt of carboxylate ion. Now we can say that due to the presence of carboxylic acid, hydrogen bonding is also present. In X. In Y, van der Waals forces of attraction are present as it is ester. In Z we have ionic bond between sodium and oxygen. So due to the presence of ionic bonding, the boiling point of Z should be the highest one. So we can say that Z has the highest boiling point. On second number, we must have hydrogen bonding as hydrogen bonding is stronger force as compared to van der Waals forces of attraction. So X is on second number. and on third number we should have van der Waals forces. Boiling point is actually the energy that is required to overcome these intermolecular forces of attraction. Correct answer is therefore B. Question 4. The structure formula of alliin is shown. This is the compound. They've asked about this X, Y and Z bond angles. What are the approximate bond angles X, Y and Z in a molecule of alliin? To find out the bond angles, you must know the hybridization of carbon that is present. If the carbon present is making one double bond and two single bonds, then the hybridization is always sp2. If the carbon present is making 4 single covalent bonds, then hybridization is sp3. Whatever molecules or elements surround this carbon, for example we have A, B and C, all these 4 will be on the same plane, and when they are all on the same plane, the bond angle must be 120 degrees. While in sp3, let's suppose we have these atoms surrounding carbon, then these are not in the same plane and the bond angle is 109 as the structure is tetrahedral. sp2 carbon always has trigonal structure. So the bond angle in X should be 120 degrees as the carbon is sp2 carbon. Bond angle in Y should also be 120 degrees because this carbon is also sp2 carbon. Bond angle in Z should be 109 as the carbon is sp3. Correct answer is therefore C. Question 5. Flask Q contains 5 decimeter cube of helium at 12 kilopascals pressure. Flask R contains 10 decimeter cube of neon at 6 kilopascals pressure. If the flasks are connected at constant temperature, what is the final pressure? This 5 decimeter cube represents the volume of helium in flask Q, and this is the pressure of helium in flask Q. So we can represent this by P1 and V1. Next is flask R. We have 10 decimeter cube of neon, which is the volume, so it could be represented as V2, while the pressure is represented as P2. Now according to Boyle's law, at constant temperature, which is given, pressure into volume is always constant. This means that P1 into V1 will be equal to P2 into V2. In this case, we have Q and R2 flasks that are connected together, so we can write P1 V1, which is for flask Q, plus P2 V2, which is for flask R. It is equal to, when both are combined together, so that is equal to P3 into V3. Now putting values, P1 is 12, V1 is 5, so 12 into 5, it comes equal to 60. For P2 V2 we have 6 into 10. Again this is equal to 60. For P3 V3 we need to find the final pressure, which is P3, and V3 is the final volume, which is the collective volume of these two. So 10 decimeter cube and 5 decimeter cube both combine together to form 15 decimeter cube, which is V3. Now we can find the value of P3. So 120 equals P3 into 15, or P3 equals 120 divided by 15, and this comes equal to 8. Correct answer is therefore A. Question 6. Sodium chloride, water and air represent 3 states of matter. First one is solid, second one is liquid, third one is gas. Which row is correct? We have the properties of sodium chloride, water and air. Part A. In sodium chloride, the particles are held in rigid structure. This is true because ionic bonding is present. and we have lattice structure that is present. Part B, particles are stationary, there is only vibratory motion present, there is no motion present in sodium chloride solid. Part C, particles are stationary, again there is no motion present, only vibrations are present. Part D, resistant to change of shape. Now solid cannot change shape on its own, there must be energy provided for solid to change its shape. In water we have liquid properties, so it can easily be compressed. This is untrue because liquid cannot be easily compressed. Then we have particles move. This is true because the particles are always in motion in liquid state. Particles are not stationary, cannot easily be compressed. This is true statement. Moving towards gas, we have air which can easily be compressed. This is true because there are a lot of empty spaces among the molecules. Cannot easily be compressed. This is untrue. Particles move. Yes. Can easily be compressed. This is true. So all three statements are true for part D. Question 7. The reaction pathway diagram for the catalyzed reaction and the uncatalyzed reaction between nitrogen and hydrogen is shown. Nitrogen combines with hydrogen to form ammonia. This is a reversible reaction, which letter represents the activation energy for the first step in the decomposition of NH3 in the presence of a catalyst. Now what catalyst does is that it reduces activation energy by providing alternate pathway. Now as they are asking about the decomposition of NH3, it means that the reaction is on the reverse side, as NH3 is being decomposed to form nitrogen and hydrogen. So this is the reactant and this represents the product. Now there are two ways for the reactant NH3 to convert into products, N2 and H2. One is C, one is D. Now C represents the activation energy of the decomposition of NH3 without the presence of catalyst. This is because this one is greater. And D represents the activation energy with catalyst. On moving further, we can see that another activation energy is also present. So D represents the activation energy for first step, while B represents the activation energy for the second step in decomposition. So correct answer is D. Looking at the other things, we have A, which represents the activation energy for this reactant to convert into ammonia without catalyst. This is the activation energy for forward reaction without catalyst. Now B represents the activation energy for the forward reaction with catalyst. And similarly, D will represent the activation energy for forward reaction with catalyst. B is the step 1 in forward reaction and D is the step 2. According to this question, the answer is part D. Question 8. Nitrogen and oxygen can react together to form nitrogen monoxide NO. The reaction is endothermic in nature. What is the bond energy for the bond between the atoms in NO? This enthalpy change represents the overall enthalpy change for the reaction. So we can write delta HR, which is equal to the energy involved in bond breaking and energy involved in bond forming. So we can represent bond breaking by delta H1, bond forming by delta H2. So delta H1 is the energy required to break these bonds and del H2 is the energy released from forming this bond. Now from data booklet we can find the values for breaking N triple bond N. The energy required is 944 kilojoules per mole. For breaking double bond in oxygen, we have 496 kilojoules per mole energy. So combining these two, we can find delta H1. As this is bond breaking, so it is always endothermic and the sign is positive. So 496 plus 944, this is for delta H1. The bond formation in NO, the energy can be represented by X, as there are 2 moles, so we can write 2X. Now 2X is the energy released, that is in bond formation. Now we know that energy released is always exothermic in nature, so for delta H2 we can write negative 2X. This is because the bond is being formed and the energy will be released. Total energy is given, which is overall energy of the reaction. It is 180. Now we can rearrange the equation. X equals 630 kilojoules per mole. This represents the bond energy between nitrogen and oxygen. Answer is therefore A. Question 9. The equation for a redox reaction is shown. This represents the equation which species is being oxidized in this reaction. We can find the changes in oxidation states. We have tin chloride SnCl2. In this, there are 2 chlorine atoms. The oxidation state on one chlorine atom is -1. So for 2, it will be -2. As overall charge is 0, so negative charge is equal to positive charge. So for tin, it should be +2. Similarly, for one chlorine, we have -1. As there are 2 chlorine atoms, so -2 is the oxidation state. Mercury must have opposite oxidation state, which is +2. Then in tin chloride, we have 4 chlorine atoms, so -1 on each chlorine, -4 for 4 chlorine atoms. So as the overall charge is 0, so tin must be +4. For Hg2Cl2, the oxidation state of one chlorine is -1. For 2, it should be -2. So for mercury, it should be opposite, which is +2. As there are 2 mercury, so oxidation state on one Hg should be +1. We can see that the oxidation state of chlorine has not changed in the reactants and products. It is -1. The oxidation state of tin has changed from +2 to +4. This is oxidation. The oxidation state of mercury, which was +2 in the reactant side, has changed into +1 on the product side. So therefore this is reduction. Correct answer is therefore A. Question 10. 3.6 moles of hydrogen gas and 2.0 moles of iodine vapors are placed in a reaction vessel, which is then sealed and maintained at a constant temperature. The equation for the reaction is shown. H2 combines with I2 to form HI. At equilibrium, 3.20 moles of hydrogen remains. All the reactants and products are gaseous. What is the value of Kp under these conditions? Let's first find the number of moles of these reactants and products at equilibrium. We have H2, I2 and HI. First, we can write the initial number of moles. Then we can write the change in number of moles. And then we can find the number of moles at equilibrium. Also from the balanced equation, the ratio of number of moles is 1 for hydrogen, 1 for iodine and 2 for HI. So initially we had 3.6 moles of hydrogen and 2 moles of iodine. So we can write 3.6 and 2. As the reaction has not started yet, so there is no product, the number of moles of product will be 0 initially. Then we can find the change in the number of moles. In the question it says that at equilibrium 3.2 moles of hydrogen remain. So from 3.6, 3.2 remains. It means that the change is 0.4, which can be obtained by subtracting these two. So we can say that hydrogen has decreased by 0.4 moles. As the ratio between hydrogen and iodine is same, it is 1 to 1. So therefore the decrease in number of moles will be the same. Iodine will also decrease by 0.4, so 2 minus 0.4, the remaining is 1.6 moles. As the reaction proceeds, the reactant gets reduced while the product gets increased, so therefore there is an increase in number of moles of the product. As the ratio of reactant to product is 1:2, so therefore if 0.4 moles are decreased, then increase will be 2 into 0.4 and it will be positive. So it becomes 0.8. So at equilibrium we have 0.8 moles of hydrogen iodide present. Now we can use the formula Kp equals the number of moles of product, Hi raised to the power is number of moles in the balanced equation divided by the number of moles of first reactant raised to the power number of moles in balanced equation, which is 1. Similarly for iodine. Now we can put the values 0.8 at equilibrium for Hi squared, 3.2 for hydrogen and 1.6 for iodine. Now the value of Kp equals 0.125. Correct option is therefore B. Question 11. Two chemicals X and Y react together in solution to give product Z. The rate of formation of product Z at the start of the reaction was measured in 5 experiments, 1 to 5, using various concentrations of X and Y. The results are shown. These are the results. Which statement is correct? A. The rate of reaction is directly proportional to the concentration of reagent X. In order to find the effect of concentration of reagent X on the rate of this reaction, we have to keep the concentration of Y constant. Now we can study the effect of X. In Y we can see that we have 0.1, again we have 0.1, so these are the constant values, so we can take these two values and these two rates of reaction. Let's see whether this rate depends on the concentration of X or not. The concentration of X is 0.1 and now it has increased to 0.2. The concentration of Y remains constant and the rate of reaction is also constant. So it means that the rate of reaction is not directly proportional to the concentration of reagent X. So part A is wrong. Part B, the rate of reaction is directly proportional to the concentration of reagent Y. Now in order to study this, we have to keep the concentration of X constant. And only Y should increase. Let's find we have all three constants in 1, 2, 3. And the concentration of Y increases from first to second. We have doubled, then again it is doubled. Now the rate of reaction has increased 4 times and then again increased 4 times. Now we can say that by increasing the concentration of Y, the rate of formation becomes 4-fold. So for this we can write the equation: rate of this reaction is directly proportional to the square of concentration of Y. So it is directly proportional to the square of concentration of reagent Y. Again this is incorrect. Part C, the rate of the reaction is not affected by the concentration of reagent X. We have already studied that 2 times, and by increasing the concentration of X, the rate of reaction does not increase. As you can see in this one, Y is constant, only X is increasing and the rate is the same. So this is a true statement. In the last part, the rate of reaction is not affected by the concentration of reagent Y. This is untrue because by increasing the concentration or doubling the concentration of Y, the rate becomes fourfold. Correct answer is therefore C. Question 12. A sample of SiCl4 is added to cold water. Which statement describes the mixture formed at the end of the reaction? We can write the chemical equation. SiCl4, when it dissolves in water, cold water, it forms SiO2 along with HCl. Now SiO2 is seen as off-white precipitate, while HCl is seen as white fumes. These white fumes of HCl can dissolve in solution in water to form acidic solution. Part A, acidic solution. We have acidic solution with no precipitate. This is incorrect because SiO2 is off-white precipitate. Part B, acidic solution with white precipitate. C, neutral solution. D, neutral solution. Part B is therefore correct. Question 13. L and M are elements in period 3 of the periodic table. The oxide of L is solid at room temperature. This oxide has giant structure. The chloride of L does not react with water. Argon is the only element in period 3 with a lower melting point than M. Which formula represents the compounds of elements L and element M? In given elements we have sodium, magnesium, aluminum, phosphorus, sulfur, chlorine. Now for oxides we can see that the oxide of sodium, magnesium, aluminum and phosphorus, they are solid at room temperature. Among these oxides, the oxides of sodium, magnesium and aluminum have giant structure, so it could be sodium, magnesium, aluminum. The chloride of L does not react with water. This is true for the chloride of sodium, which is NaCl. It only dissolves in water. Magnesium chloride also only dissolves in water. It does not react. All other chlorides, they react with water, so it could be sodium or magnesium. Third is that argon is the only element in period 3 with a lower melting point than M. While finding out the melting point of these elements, in sodium, magnesium, aluminum, the melting point increases because of strong forces of attraction between the atoms in metallic bond. Then we have phosphorus, which exists as P4 molecule, sulfur exists as S8, chlorine exists in the form of Cl2, and then we have argon. So chlorine is the only one that has low melting point as compared to argon. So the answer is either sodium chloride or magnesium chloride. As only sodium chloride is given, the answer is C. Question 14. A farmer requires a solid compound to raise the pH of the soil in the field from 5.5 to above 6. Which compound could the farmer use? Among the given one, we have ammonium salts, then we have ammonium nitrate, which is also ammonium salt. Then we have calcium hydroxide, which is slightly soluble in water and it can raise the pH of the soil. As this is basic in nature, it can neutralize the acid present in the soil and pH will increase. Last one is calcium nitrate. Again, this is a salt. It can only increase the concentration of nitrate ions. As no other can increase the pH, only calcium hydroxide is the correct answer. Question 15. Z is an anhydrous compound of group 2 element. When it is heated, Z undergoes thermal decomposition to produce two different gases. Z has relatively low thermal stability compared to other group 2 compounds containing the same anion as Z. What is compound Z? In given options, we have carbonate, nitrate, again carbonate and nitrate. We can write the decomposition equation for carbonates. This is metal of group 2, metal carbonate decomposes to give metal oxide, which is in solid form, and also CO2, which is in gaseous form. So only one gas is obtained when carbonate is decomposed, but in the question it says it decomposes to give two different gases. So therefore this is not carbonate. For nitrate, we can write the equation. We have metal of group 2 and this is the nitrate. It decomposes to give three things. One is metal oxide, which is solid. Then we have nitrogen dioxide, which is gaseous, and we also have oxygen. So it could be nitrate. Either it is barium nitrate or magnesium nitrate. Now you should remember the decomposition of nitrate. As we move down in group 2, the nitrate becomes more thermally stable. This is because the size of cation increases down in the group. So barium nitrate is below in the group as compared to magnesium nitrate. So therefore the thermal stability of magnesium nitrate will be less than barium nitrate. Correct answer is therefore D. Question 16. Which row gives mixtures that both result in the oxidation of a halide ion? In A, we have silver nitrate and sodium chloride. Now silver nitrate aqueous can react with sodium chloride to form silver chloride and sodium nitrate. Now the oxidation state of Cl has not changed. Cl is -1 in the reactant side and -1 on the product side. So therefore it is not this one. For second reaction, we have sulfuric acid aqueous and hydrogen iodide aqueous. These can react together to form iodine, sulfur dioxide and water. The oxidation state of iodide has changed from -1 to 0, so therefore this is oxidation. In second one, we have bromine that reacts with sodium chloride. As bromine is less reactive as compared to chlorine, so bromine cannot displace chlorine. So therefore no reaction will occur. Second is the concentrated H2SO4 aqueous and HCl. Now concentrated H2SO4, it cannot oxidize chloride ion into chlorine gas. It can only oxidize iodide. For third reaction, we have chlorine aqueous and sodium bromide. Now chlorine can displace bromine to form sodium chloride along with Br2. Now Br -1 has gone into 0 oxidation state, so therefore this is called oxidation, while chlorine has gone from 0 to -1, which is reduction. In second reaction, we have 2-bromopropane that reacts with sodium hydroxide ethanolic. Now elimination reaction will take place and this Br will be removed along with hydrogen from adjacent carbon and double bond is going to be formed. The oxidation state is same in the reactant and on the product side, so therefore this is incorrect. In the last one, we have bromine and sodium iodide. Now bromine can displace iodine to form this product. We have NaBr and iodine. This has gone from -1 to 0, which is oxidation. Then we have concentrated sulfuric acid and sodium bromide solid. These can react together to form NaHSO4 along with HBr. This HBr can further react with sulfuric acid concentrated to form bromine. SO2 and water. Now bromine has changed from -1 in the reactant side to 0 on the product side, so therefore this is increase in oxidation state, which is oxidation. So halide gets oxidized in both parts of this part D, therefore D is the correct answer. Question 17. Chlorine gas is widely used to treat contaminated water. When chlorine is added to water, which chemical species present is responsible for killing bacteria? When chlorine is added to water, this reaction takes place. Chlorine reacts with H2O and it forms HCl along with HClO. Now this HClO is unstable, it decomposes again to form HCl and atomic oxygen. This atomic oxygen kills bacteria. Now this is formed from HClO, which has two parts. ClO is negative, H is positive. As oxygen is produced from this part, therefore correct answer is D. Question 18. What is environmental consequence of the uncontrolled use of nitrate fertilizers? Now due to the presence of excess nitrates, we have a process called eutrophication, which causes depletion of oxygen, or you can say dissolved oxygen. And it therefore kills living organisms such as fish. First one is acid rain. Now oxides of nitrogen and oxides of sulfur, they are responsible for acid rain. P part is low oxygen levels in water streams. This is true. C part is ozone depletion. Now ozone depletion is caused by chlorofluorocarbons and radicals. While greenhouse effect, this is caused by carbon dioxide, methane and water. Correct option is therefore B. Question 19. Ammonia gas NH3 and hydrogen sulfide H2S, they react together to form the salt ammonium sulfide NH4(2S). Ammonium sulfide dissolves in water to produce an orange alkaline solution. This is ammonium sulfide, it forms aqueous ammonia and NH4SH. The addition of sodium hydroxide to this solution produces a gas X. The addition of HCl aqueous to a separate portion of this solution produces a gas Y. X and Y could represent different gases or identical gases. What are the identities of X and Y? Now we have alkali and we have ammonium salt. As we know that ammonium salt reacts with alkali to form ammonia, salt and water. So we can write this equation. We have ammonium salt, we have alkali. The product will be salt, NaSH, along with water, and ammonia gas is released. So gas X is NH3. Now the second reaction is of HCl with these. First one is NH3. It can react with HCl aqueous to form ammonium chloride salt. There is no gas produced. While NH4SH can also react with HCl to form ammonium chloride. And we have H2S gas that is also produced. Another reaction can also be written for this. We have ammonium sulfide NH4 2S. This can react with HCl to form ammonium chloride, and again H2S gas is produced. Correct option is therefore C. Question 20. Compound P is treated with an excess of hydrogen gas in the presence of nickel catalyst. The product Q is fully saturated. This is compound P, which is then saturated into compound Q. What is the number of chiral carbon atoms in the product Q? Now in this compound we have double bonds that are present. Alkene is present, as we know that in the presence of nickel catalyst and hydrogen, all double bonds will convert into single bonds. So we can consider all these double bonds as single bonds in compound Q. Now let's find chiral carbon. Chiral carbon is the one that is attached with 4 different elements or 4 different groups. First one is this one. We have one hydrogen atom also present, CH3 group. Then we have this group and this group. All 4 are different, so therefore this is chiral carbon. Then we have this carbon which is bonded to 2 similar hydrogen atoms. This is also bonded to 2 similar hydrogen atoms, so therefore these are not chiral. Again, this carbon is bonded to 3 similar hydrogen atoms. This is also not chiral. Now looking at this carbon, we have 3 single bonds and 1 hydrogen is also present. This carbon is chiral because all 4 groups are different. One is this one is hydrogen, one is this group, and one is this group. Now moving towards this carbon, we have 2 identical hydrogen atoms, 2 identical hydrogen atoms on this one. Now looking into this one, we have 1 hydrogen atom also present, and all 4 groups are different, so therefore this is also chiral. For this carbon we have 2 bonds, 2 hydrogen atoms are present, 2 for this one, 2 for this one, all 3 are not chiral. Then looking at this carbon atom, we have 1 hydrogen bond also present. This is chiral because all 4 groups are different. Now moving towards this carbon, we have 2 identical hydrogen atoms. Again on this one we have 2 identical hydrogen atoms. On this one we have 1 hydrogen atom. And all 4 groups are different, so this is also chiral. So far we have 5 chiral carbons present. Now moving towards this one, we have 2 identical CH3 groups attached to the same carbon atom. Therefore this carbon is not chiral. As 5 chiral carbons are present in the product compound Q, so therefore answer is B. Question 21. Hexadecanoate-1012-diene-1-ol is produced by silk moths from hexadecanoic acid in a 3-step enzymatic process. This is hexadecanoic acid. We have carboxylic acid functional group, and as it is hexadeca, so therefore it means we have 16 carbon atoms in the long chain. In step 1 we can see there is no change in functional group. Alkane is converted into alkene. Then in step 2 again carboxylic acid is the same. Instead of one alkene, again another alkene is produced. Then we have carboxylic acid reduced into alcohol, and the number of alkenes remain same. Now we can see the changes. We had single bond which is now converted into double bond. It means there is a loss of hydrogen. Alkane is converted into alkene. Then in next chain we have same number of carbon atoms in the long chain, but another double bond has come into existence, which means loss of another H2. Then in third step we can see that the double bond is the same. There is no change in double bonds. But on this side we can see that carboxylic acid has converted into primary alcohol. Now this is reduction, and it can be carried out in the presence of LiAlH4 and dry ether. In step 1 and in step 2 we have seen there is a loss of hydrogen, so therefore loss of hydrogen is called oxidation. In step 3 it is reduction process. Correct answer is therefore part D. Question 22. Compound X can be converted into compound Y in a single step. This is compound Y. We have ketone. We have carboxylic acid. What could be the identity of X? In the product we can see that we have ketone on second carbon, and we have carboxylic acid on first carbon. As these are all ring structures, so therefore alkene the bond must be broken. In order to produce ketone, the double bonded carbon must be bonded to two alkyl groups. And in order to form carboxylic acid, the double bonded carbon in alkene must be bonded to one alkyl group and one hydrogen. In the product we have 1, 2, 3, 4, 5, then subsequent 6 carbon atoms in the long chain. It means that the double bond must be between second and sixth carbon atom. Let's look at part A. We have 1, 2, 3, 4, 5 and then subsequent on 5 and then 6. In part B we have 1, 2, 3, 4. Substituent is on 4th, which is wrong because the substituent position cannot be changed. In part C we have 1, 2, 3, 4, 5. Substituent on 5th, and then we have 6 and 7 carbon atoms in the long chain, which is not true because there must be 6. In the last part D we have 1, 2, 3, 4, 5, 6. Substituent is on 6th carbon atom while it should be on 5th. Only one option is left. We have 1, 2, 3 on second carbon atom. We have two alkyl groups. One is this one is this one. So it will be converted into ketone. Yes, it has converted into ketone. Then on 5th carbon atom we have methyl functional group. This is also true. Then on 6th carbon atom we have one hydrogen atom, one alkyl group, so this is oxidized into carboxylic acid. Correct answer is therefore A. Question 23. Methane, CH4 and bromine react by free radical substitution. P and Q are involved in the reaction mechanism. P and Q are both involved in propagation steps as reactants, are both involved in termination steps as reactants. What could be P and Q? For bromination of methane, we can divide the steps into three parts. First one is initiation, in which radical is formed. So bromine converts into bromine radicals. Now in second step we have propagation, in which methane will react with these radicals to form methyl radicals along with HBr. These methyl radicals can also react with Br2. To form methyl bromide along with bromine radical. These steps will continue until all the hydrogen atoms in CH4 are replaced by Br. In termination steps, two radicals can come together to form neutral product, or CH3 radicals can come together to form alkane. Or CH3 radical can also react with Br radical to form neutral methyl bromide. Now P and Q are both involved in termination steps, and in termination steps we can see that all radicals are present. These radicals are also present in propagation step. So the correct answer could be CH3 and Br. Question 24. A few drops of true bromopropane were placed in test tube. An equal volume of aqueous silver nitrate was added. A precipitate was formed. The experiment was repeated with 2 iodopropane. Which row is correct? First one is the color of precipitate from 2 bromopropane plus silver nitrate. Second is the faster rate of reaction. In 2 bromopropane we have 3 carbon atoms, and on second carbon atom we have bromine atom attached. In 2 iodopropane we have 3 carbon atoms, and on second carbon iodine is attached. With silver nitrate, bromopropane will form AgBr, which is cream precipitate, while with iodopropane Ag plus will produce AgI, silver iodide, which is yellow in color. So for bromopropane the answer is cream. Now looking at the rate of reaction, we have 2 bonds being broken, one is CBr, one is Ci. Now the energy required to break CBr bond is 290 kilojoules per mole, while to break carbon iodine bond the energy required is 228 kilojoules per mole. As less energy is required for this breaking, so therefore the reaction will be faster in iodopropane. Correct answer is therefore C. Question 25. Sodium methoxide NaCH3O reacts with 2-chloro-2-methylpropane in a nucleophilic substitution reaction. The nucleophile is CH3O negative ion. Which row is correct? First one we have to find the intermediate or transition state, then we have to find the product. 2-chloro-2-methylpropane is like this. We have propane as it is 3 carbon long chain. On second carbon we have chloro, we also have methyl group. Now this is an example of tertiary alkyl halide because this carbon is directly attached with 3 other carbon atoms. Now tertiary alkyl halide always undergoes nucleophilic substitution, which is SN1. And what happens is that first this bond is broken by hydrolytic fission and we have these 2 products, CH3, CCH3. This one becomes positive and Cl is removed. Now in second step, as the nucleophile is CH3O negative, so this will attack this carbocation and form this product. We have CH3O carbon, then 3 methyl groups are also attached. So first is the intermediate. This is the intermediate or transition state. C and D are not true. These are for primary halogenoalkanes. Now this product formed can also be written like this. We have 3 methyl groups attached with this carbon, so we can write 3CH3. Then we have this carbon atom, this oxygen atom, and this CH3 is also present. This is similar to this product, therefore answer is A. Question 26. Alcohol X reacts with concentrated sulfuric acid to produce a mixture of products. 2 of the products are structural isomers of each other. What could be X? Now you should remember the reaction. Alcohol reacts with concentrated sulfuric acid to form alkene along with the removal of H2O. Structural isomers are those compounds that have same formula, same molecular formula, but different structures. A is hexane 2-ol. In hexane we have 6 carbon atoms, and 2-ol means we have alcohol group on second carbon atom. Now in the presence of concentrated H2SO4, alkene is formed. That alkene could be either between these 2 carbon atoms or these 2 carbon atoms, because hydrogen is removed from adjacent carbon and H2O is removed. So first product could be this one. Second product could be this one if hydrogen is removed from this carbon and OH is removed from this carbon. Our first product is alkene, as double bond is between first and second carbon atom, so it is hex 1-ene. While in second product we have double bond between second and third carbon atom, so it is hex 2-ene. Both the products have same general formula C6H12, and the structures are different as the position of double bond has changed. So they are structural isomers of each other, so therefore A could be the correct answer. B is pentane 1-ol. In pentane we have 5 carbon atoms. 1-ol means that OH is attached with the first carbon atom. Now in the presence of concentrated sulfuric acid, water will be removed and hydrogen is removed from this adjacent carbon atom. As there is no other adjacent carbon atom, so therefore only one product is possible, which is this one. And the name is pent 1-ene. For part C we have pentane 3-ol. It means that OH group is attached on the third carbon atom, and in total we have 5. Now hydrogen can be removed from this adjacent carbon atom or this adjacent carbon atom, so double bond could either come between these 2 carbons or these 2 carbons. 2 products are formed, and if the double bond is between these 2 carbon atoms, then this product is formed. While naming, we start numbering from the carbon that gives least number to the double bond. As we can see that the double bond is present on same carbon atom in these 2 products, so therefore these are not different products, they are the same. And the name for both is pent 2-ene, along with water molecules that are removed. Last one is propane 2-ol. In propane we have 3 carbon atoms, and 2-ol means OH is on second carbon. So either hydrogen is removed from this corner carbon or from this corner carbon. So again both products are same, either this one or this one. The double bond is present between first and second carbon atoms, so therefore the name for both will be prop 1-ene, along with water molecules. As these are the same compounds, not the isomers, so therefore all these are incorrect. Correct answer is therefore A. Question 27. Which reaction will form a strong organic base? Part A, ethanol and acidified sodium dichromate. Now acidified sodium dichromate is oxidizing agent. And it can convert ethanol into aldehyde. as no base is formed, so therefore this is wrong. Then we have ethanol and hot aluminum oxide. This causes elimination reaction and water is removed from ethanol and alkene is formed. Hydrogen will be removed from adjacent carbon. This will form double bond along with the removal of H2O. Again, no base is formed, so therefore this is also wrong. Part C is ethanol and sodium. Sodium is a metal. It can react with alcohol to form alkoxide along with hydrogen gas. The product form will be O negative, Na positive. This is sodium ethoxide along with hydrogen gas. Now this product is basic ionic compound. Where ethoxide is a strong base, so therefore part C could be correct. In the last one we have ethanol and hydrogen chloride. This can form chloroethane along with water. No base is produced, so therefore this is incorrect. The only one that produces strong base is part C. Question 28. Which reaction mechanism for the formation of C2H5CHOHCN is correct? On the reactant side we have aldehyde, again we have aldehyde in part B. This carbon attacks partial positive carbon atom of carbonyl group. This electron is removed and it moves towards oxygen. Then oxygen becomes negative charge. This one is true. Now the lone pair present on this oxygen, it will attack this hydrogen to form OH. The direction of arrow is incorrect. It should be from oxygen to hydrogen. In part B, again we can see that the direction of arrow is incorrect. It should be from lone pair to the partial positive carbon atom. This one is correct. In part C, this arrow is correct. Carbon is partial positive, it is not partial negative, and oxygen is partial negative, so this is wrong. In part D, the arrow is correct. Carbon is partial positive, oxygen is partial negative, electrons move towards oxygen. Then this lone pair on oxygen, it attacks H plus to form this product. Correct answer is therefore D. Question 29. The synthesis shown may be used for the production of propane 1-ol, which is alcohol. We have nitrile. In step 1 it converts into compound, then in step 2 it converts into alcohol. Which row gives the correct reagents for step 1 and step 2? In the equation we can see we have 1, 2, 3 carbons and nitrogen is also present, so this is propane nitrile. And on product we have 1, 2, 3 carbon atoms and this is propane 1-ol. Now you should remember that propane nitrile or any nitrile can be converted into alcohol by this step. We have this nitrile. It is first refluxed in the presence of acid. So acid hydrolysis take place. And this nitrile is then converted into carboxylic acid. Now carboxylic acid can be reduced by LiAlH4 to form respective alcohol. So first step is acid hydrolysis of propane nitrile. So in first step, propane nitrile is converted into carboxylic acid by using HCl, H2O and reflux. The product form will be CH3, CH2, COOH, which is carboxylic acid, along with the salt of nitrogen. Then second step, we are going to use LiAlH4, which is going to convert this carboxylic acid back into primary alcohol. Correct answer is therefore B. Question 30. The molecular formula of Z is C4H8O. The infrared spectrum of Z is shown. This is the infrared spectra. We have different peaks. What could be Z? In the given options, they have given ketone, alcohol, carboxylic acid, alkene and alcohol. Now this peak between 3200 to 3600 is because of presence of alcohol. This peak at 2850 to 2950 is because of CH in alkane. And this peak could be because of two things. Either it is of alkene, which is from 1500 to 1680, or it could be from carbonyl carbon, which is from 1670 to 1740. Aldehyde and ketone, carbonyl carbon. As in part A, there is carbonyl carbon present, but no alcohol peak should be present because there is no alcohol group, so A is incorrect. In part B, we have alcohol compounds, so therefore only this peak should be given. This peak should be absent. As there is no carbonyl carbon or no alkene, so therefore B is also incorrect. In part C, we have carbonyl carbon, we also have OH. Now this OH should give peak between 2500 to 3000. And it is absent. So therefore C is also wrong. In part D, we can see we have alkene functional group whose peak is present 1500 to 1680. We also have alcohol functional group that is present whose peak is also present between 32 to 3600. We also have carbon hydrogen bonds that are present whose peak is between 2850 to 2950. So D could be the correct option. Now let's find the molecular formula of this compound. We have 1, 2, 3, 4 carbon atoms, 8 hydrogen atoms, 1 oxygen. So this molecular formula is similar to the one given in the question. Therefore, correct answer is D. Question 31. In which ions are the number of electrons equal to the number of neutrons? We can find electrons by looking at the charge. The proton number is 9, the charge is -1, so addition of 1 electron takes place. So 9 plus 1, it becomes 10 electrons. Number of neutrons can be found by subtracting the mass number from atomic number. 19 minus 9, it becomes 10 neutrons. Similarly, in phosphorus, we have -1 charge, so 15 protons plus 1 electron, it becomes 16 electrons. And 31 minus 15 becomes 16 neutrons. Part 3, we have sodium positive, so 1 electron is lost. 11 minus 1 will become 10 electrons. 23 minus 11 gives 12 neutrons. As electrons and neutrons are equal in first and second one, therefore answer is B. Question 32. Compound X is a straight chain hydrocarbon with a molecular mass of 84. What can be determined about X? Now X is a hydrocarbon, which means it contains carbon as well as hydrogen. So as the atomic mass of carbon is 12, dividing 84 by 12, the answer is 7. So it means that in the long chain there must be less than 7 carbon atoms. So if it is an alkane, it should be C6, H14. If it is alkene, it should be C6, H12. If this is alkyne, it should be C6, H10. Let's find the molecular mass for 6 carbon. 12 into 6 is 72 plus 14 hydrogen. So it comes equal to 86. For 6 carbon and 12 hydrogen in alkene, we can find the molecular mass 12, 6, 72 plus 12. So it comes equal to 84. For alkyne, 72 plus 10, which comes equal to 82. So among these three, we can conclude that this compound X is an alkene. Now first one is what can be determined about X. Number 1, empirical formula. The empirical formula of C6H12 will be CH2, which is the simple ratio of carbon and hydrogen. So this can be determined. Second is the molecular formula. We have already determined that, C6H12. Third is whether X contains a carbon-carbon double bond or not. We already know that as it is alkene, so there is a carbon-carbon double bond that is present. All three options are correct. Answer is therefore A. Question 33. When a sample of ammonium chloride is warmed, it decomposes into ammonia and hydrogen chloride gas. NH4Cl converts into NH3 along with HCl. This is reaction 1. When the mixture of hot ammonia and hydrogen chloride gases hit a cold surface, for example, this ammonium chloride first converts into these gases, which then hit a cold surface. This is the cold surface. A white solid of ammonium chloride reforms. So solid ammonium chloride is reformed. The statements are correct. Number 1, reaction 1 is in dynamic equilibrium. Now for dynamic equilibrium, there must be a closed system. As there is no closure, no boundary is present, so therefore this is incorrect. Number 2, reaction 1 is reversible. As ammonium chloride first converts into ammonia and HCl upon heating, and upon cooling the products convert back into the reactant, so therefore this is true, that this reaction is reversible as ammonium chloride is formed again from ammonia and HCl. Number 3, reaction 1 is an endothermic reaction. As we are providing heat in reaction 1 and ammonium chloride is converting into these products, so therefore expenditure of heat means that the reaction is endothermic in nature, as it absorbs heat in order to decompose. As options 2 and 3 are correct, answer is therefore C. Question 34. Hydrogen chloride gas is formed by the reaction shown. We have hydrogen gas that reacts with chlorine gas to form HCl gas. What will change the average kinetic energy of the reactant gas particles? Now kinetic energy is the energy due to motion, and it can be increased or decreased by changing temperature. Number 1, increasing the temperature. Yes, it will increase the average kinetic energy, and increasing the concentration of hydrogen. Now this will increase the rate of reaction. The concentration does not affect the average kinetic energy. Overall, by increasing the temperature and increasing the concentration, the average kinetic energy will be increased. Number 2, cooling the reaction mixture. As the temperature is being decreased, so therefore it will decrease the average kinetic energy. Again, second part is adding a catalyst. It does not affect the average kinetic energy, but it increases the rate of reaction. Overall, due to cooling, the average kinetic energy will be reduced. Third part is adding a catalyst. It will only lower the activation energy. It does not affect the average kinetic energy, and increasing the concentration, again it only increases rate of reaction, does not affect the average kinetic energy. So overall there is no change in average kinetic energy of gas particles. Option 1 and option 2 are correct. Answer is therefore B. Question 35. Which oxides will cause a change in pH when added to water? First one is calcium oxide. Calcium oxide can dissolve in water to form calcium hydroxide. And it can produce calcium plus 2 and OH negative ions. Due to the production of OH negative, the pH will be increased. Second is aluminum oxide. Now aluminum oxide does not react or dissolve in water. No change in pH is observed. Third one is silicon dioxide. Again, silicon dioxide does not react or dissolve in water. No change in pH will be observed. As only first option is correct, answer is D. Question 36. Which reaction routes can be used to make a pure sample of barium sulfate? First one is barium metal. When heated in the presence of oxygen, it forms product which is barium oxide. Then barium oxide can react with dilute HCl to form salt, barium chloride along with water. This barium chloride product can be reacted with dilute sulfuric acid to form barium sulfate, which is insoluble, solid. It can be filtered, washed and dried to obtain pure barium sulfate. In second one, we have barium nitrate. When strongly heated in air, nitrate decomposes into barium oxide, nitrogen dioxide and oxygen gas. Other two are gases, so therefore barium oxide is the only solid product. Again, in an excess of water, it will form barium hydroxide because it is quite soluble in water. Now this is base and it can react with this acid to form barium sulfate along with H2O. Again, barium sulfate is insoluble solid, so it can be filtered, washed and dried. Third one is barium hydroxide, which is base. It can react with acid to form salt, barium nitrate along with water. This product barium nitrate can react with dilute sulfuric acid to form barium sulfate. This barium sulfate is insoluble, so it can be filtered, washed and dried to obtain pure barium sulfate. All three methods can be used to obtain pure barium sulfate, so therefore answer is A. Question 37. Cortisone is a synthetic hormone. This is the structure of cortisone. Which classes of alcohol does this molecule contain? We have primary, secondary and tertiary alcohol. Now you should remember that if the carbon bonded with the OH is bonded to no other carbon atom, or if it is bonded to only one other carbon atom, then it is primary alcohol. If the carbon bonded to OH is further attached directly with two other carbon atoms, then it is secondary alcohol. And if this carbon is attached with three other carbon atoms directly, it is tertiary alcohol. Let's look at the OH groups. This is OH, this is OH and this is OH. We only have three alcohol groups. So we can look at these 3 carbon atoms. This carbon atom is directly attached with 2 other carbon atoms. One is this one is this one. So therefore this is secondary alcohol functional group. This carbon of OH is further directly attached with 3 other carbon atoms, 1, 2, 3. So therefore this is tertiary alcohol. And this carbon atom is directly attached with only 1 carbon atom, so therefore it is primary alcohol. As all 3 options are correct, answer is A. Question 38. Which changes are commonly involved in the formation of an addition polymer? Let's do an example of addition polymer. For example, we have alkene. These are the monomers of alkene. They can combine together in such a way that double bond has converted into single bond. A new bond is formed between these 2 carbons. Then double bond is converted into single bond, and again so on. Hydrogen atoms remain same. First one is the formation of a sigma bond. As we can see that new sigma bond is formed between these 2 carbon atoms, so therefore this is true. The breaking of a pi bond, as we can see that double bond has converted into single bond, so this is also true. The change in hybridization of the orbitals of carbon from sp2 to sp3. Now a double bonded carbon is always sp2 hybridized, while the hybridization of carbon making 4 single covalent bonds is sp3. So there is a change from sp2 to sp3 carbon atom, and the bond angle changes from 120 degree to 109. This is also a true statement. All 3 options are correct. Answer is A. Question 39. Which alcohols can be oxidized to form an organic compound which will give colored precipitates with both 2,4-DNPH and alkaline aqueous iodine? Now you should remember that 2,4-DNPH gives colored compound with aldehydes and ketones. While alkaline aqueous iodine gives colored product only with product having methyl group directly attached with carbonyl carbon. This must be present. Looking at the first one, we have this carbon atom which is directly attached to 2 other carbon atoms, so this is secondary alcohol, and secondary alcohol is oxidized to ketone, so it will give this product. This is a ketone, and it will give colored product with 2,4-DNPH as it is a ketone. But with alkaline aqueous iodine, there must be CH3 attached with the carbonyl carbon, as no CH3 is attached with the carbonyl carbon directly, so therefore this will not give colored product with alkaline aqueous iodine. In second part, we have secondary alcohol. Because this carbon is directly attached to 2 other carbon atom, we also have a ketone, as this carbon is attached to 2 alkyl groups. So upon oxidation, ketone is not affected. Secondary alcohol will convert into ketone. Now we have 2 ketone groups in the product. As we can see that the ketones are present, so therefore 2,4-DNPH will give positive result and colored precipitate is formed. And we can also see that CH3 is directly attached to the carbonyl carbon, so therefore alkaline aqueous iodine will also give colored precipitate. In part 3, we can see that this carbon is directly attached to 2 other carbon atoms, so therefore it is secondary alcohol and it is oxidized into ketone. The product will be like this. As the product formed is ketone, so therefore it will give colored precipitate with 2,4-DNPH. Also we can see that CH3 is directly attached with the carbonyl carbon, So due to the presence of this part, it will give colored compound with alkaline aqueous iodine. As option 2 and 3 are correct, answer is therefore C. Question 40. Which mixtures form a carboxylic acid as one of the products? In first one we have ester as C double bond OO is present, and in the presence of sulfuric acid aqueous, acid hydrolysis of ester will take place, and it is divided into two parts. The portion containing carbonyl carbon will be converted into carboxylic acid, while the portion containing oxygen will be converted into alcohol. So we can draw the products. This is alcohol part, and this is carboxylic acid part. As one of the product is carboxylic acid, so therefore option 1 is correct. In second portion we can see we have carboxylate ion, which is anion. It can react with H2SO4, so H plus will be attached to this oxygen and it will form carboxylic acid as the product. As carboxylic acid is formed, this is also true. In third part we have aldehyde functional group, and in the presence of sulfuric acid, aldehyde does not give any reaction. As option 1 and 2 are correct, answer is B.
Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.